There are 7 global pressure belts. Take a look. You can see if you count them. But 4 per hemisphere, so it's a little tricky. Here are the 7. Polar high, subpolar lows, subtropical highs, equatorial low, subtropical highs, subpolar lows, polar high from north to south. Can you see that? That's 7. 1, 2, 3, 4, 5, 6, 7. However, there's 4 per hemisphere. Because if you look in the northern hemisphere, there's the polar high, the subpolar lows, the subtropical highs, and the equatorial low. In the southern hemisphere, there's the polar highs, the subpolar lows, the subtropical highs, and the equatorial low. Because what happens is the northern and southern hemispheres share the equatorial low. So it's 1, 2, 3, 4, 1, 2, 3, 4. Usually 4 plus 4 is 8. In this case, 4 plus 4 is 7. Okay? We're just going to take a look at the northern hemisphere and just deal with it in the northern hemisphere because the southern hemisphere replicates, all right? Now, per hemisphere, there are both thermal and dynamic pressure belts. There are 2 thermally induced pressure belts per hemisphere and 2 dynamically induced pressure belts per hemisphere. Thermal, like you might guess, means it has to do with temperature. Dynamic has to do with multiple factors. A deep dark secret is really it's related to temperature also, but it's multiple temperature factors. Okay, before we start, you know we have a 3D world and this is a 2D diagram. Therefore, try to envision this being spherical, and that might help a little bit, at least to internalize the way the planet is actually operating. These are the thermal pressure belts. You can see them if you know what to look for. And that's my job, to show you what to look for. Let's start at the equator. At the equator, is it hot or is it cold at the equator? Answer is hot. And what does hot air do? Hot air rises. Rising air creates what kind of pressure system? That's right, low. So you can see I circled the equatorial lows. And if you look carefully, you can see that there are also red arrows rising away from the surface of the planet, indicating that hot rising air. Therefore, the equatorial low is the first of our thermally induced pressure belts. It is exclusively the result of hot rising air, thermal. What about the poles? At the north and south poles, is it hot or is it cold at the north and south poles? Cold. And what does cold air do? Cold air subsides. What kind of pressure system is cold, subsiding, that's the key word, air going to create? The answer is high pressure. And indeed, this is how the polar highs are created. They are the result of cold, subsiding air at the poles. Take a look again at the arrows, and you can see that those arrows that I've circled are blue, indicating cold, subsiding. Therefore, the 2 thermally induced pressure belts per hemisphere are the polar highs and the equatorial low. Okay? Now a little more complicated. The dynamic pressure belts, which of course is going to be at 30 degrees north and south and 60 degrees north and south, the subtropical highs and the subpolar lows. Let's start with this. Notice the air descending at 30 degrees north and south. So find 30 degrees on there, right there, and notice that you have blue arrows pointing down, which indicates blue arrows, cold air descending. Can you see the way that looks? Okay. What's happening is this. Cold air from the equator, that's what I said, descends, creating the subtropical highs. Cold air from the equator, yeah, here's what happens. Warm air rises at the equator. But if you look at the diagram along 0, you can see that you have a red arrow going up, but then you have blue arrows that split away from those red arrows at the top. Because as that air from the equator rises 10, 20, 30, 40, even 50,000 feet high, the air, as it gets up that high, starts to get very cold. What does cold air want to do? Descend. However, it can't just descend down because there's air below it pushing it up from the equatorial low. It works something like an ornamental water fountain, if you've seen something like this, where the water jets up into the air, and then what happens is when it reaches its highest point and gravity begins to take over, the water wants to fall down, and so it kind of cascades off to the sides. This is what's happening with that air from the equator. It rises up, it cools, it wants to come down, it cascades off to the sides, and it lands right about 30 degrees north and south. This is what creates the subtropical highs, the first of the two dynamic pressure belts, right? Now it becomes even a little bit more complicated. Take a look at 60 degrees north and south. You can see that there are arrows that are moving up, red arrows and blue arrows at both of those locations at 60 degrees north and south on either side of the globe. See that? What's happening there? Well, what's happening there, see what I'm talking about right there, the red arrows around? What's happening there is this. Warm air from the subtropics meets cold air from the poles. So let's just look exclusively in the northern hemisphere because it works the same way in the southern hemisphere. Look at 30 degrees north. You can see that along the surface of the planet, headed north, away from 30 degrees north, you have red arrows indicating warm air. Then notice at 90 degrees north, where it says polar cell, notice that there are blue arrows heading away from 90 degrees north, headed south. Then notice this, that those red arrows and the blue arrows meet right about 60 degrees north and south. When they meet, the warm air is forced to rise. That rising air creates the subpolar lows. So again, the two dynamic pressure belts per hemisphere are the subtropical highs and the subpolar lows. This just means that there's multiple factors involved creating them. The two thermally induced are the equatorial low and the polar highs. The two dynamically induced are the subtropical highs and the subpolar lows. All right, we're going to come back to this diagram in the next video, but let's take a look at it now. So look at this beautiful diagram. First, this area I circled. You have the thermally induced rising air of the equatorial low. Notice the red arrows. Can you see that? The air is rising, and also notice the clouds. Rising air creates clouds. But then as you're looking at that, notice what happens as the air rises. It turns into blue arrows, and then it begins to descend down towards the earth. And it comes down right about 30 degrees north or south, but we're going to concern ourselves with the northern hemisphere. And as it comes down, notice there's no clouds there. This is the dynamically induced subtropical high of the northern hemisphere. Now look, as the air comes away from the subtropical high and heads north, you have a red arrow going north. That's going to meet blue arrows, which means cold air, of course, coming away from the polar high. Once again, where they meet at about 60 degrees north and 60 degrees south, of course, also. Notice there's clouds there. See that? Because you have rising air. The warm air is forced to rise, which creates a subpolar low. Then lastly, notice the thermally induced subsiding of the air at the polar highs.